Hi and welcome to another lecture on ordinary differential equations. Today we are going to have a short lecture on resultant and phase in trigonometric expression. Let's go take a look at the story of this topic. Okay, in many of the problems you have solved so far, you have come across an expression which is a mix of sine and cosine of the same frequency. Now, in many engineering applications, it is preferred to have just one function, either everything in terms of cosine or everything in terms of sine. For example, when you do electrical circuits, they say, okay, let's use a baseline. The baseline maybe is the voltage, or maybe it's the current or something. They try to measure everything with respect to just one line. That implies that you want to write your expressions, your trig expression, by just one function. Different textbooks use different one of these things. So some of them go with cosine, some of them go with sine. Your textbook emphasizes let's write everything in terms of cosine. So you see problems where it says write this expression as r cosine of omega t minus delta. In this situation, r is going to be referred to as resultant, or as the net amplitude, and delta is going to be the so-called phase. Sometimes they call it phase shift or phase lag or something. So this is the Greek letter delta. The transformation from one to the other is very basic. You have seen something like this in your trig class or pre-calculus or something. And the expression that connects it to is best described by a picture as opposed to trying to memorize formulas. The picture is the following. We just draw the coordinate system, the coefficient of cosine on the horizontal axis, b on the vertical axis. They could be positive or negative, either of them. So you could end up being in any of these quadrants. So what is r? R is simply the hypotenuse. R is going to be just the Pythagorean formula. And delta turns out to be this angle measured in standard fashion going counterclockwise. So cosine of delta is the ratio adjacent to hypotenuse, sine of delta opposite to hypotenuse, tangent of delta is opposite to adjacent, however you want to describe it. And then the issue is, well, what is r itself? For the amplitude, it's straightforward. We take the square root and we pick on the positive square root by default. This is taken to be a positive number. It was possible to take a negative, but we go with the positive answer. With delta, we are going to have a bit of a complication. When you use your calculator and you use tangent inverse by definition is always in quadrant 1 or 4. It does not make provisions to be here or here. So you got to be careful with that. If your a is positive, well, by default you're either in quadrant 1 or 4, and tangent inverse will be okay. It just gives you what you want. But if your a is negative, you're in either quadrant 2 or 3, and the answer the calculator gives you, it just sends you to the wrong quadrant. To fix it, you have to add pi to it yourself. So if a is negative, delta will be pi plus tan inverse. In an extreme case, when a is just 0, of course you cannot divide. Your calculator is going to object to doing any such thing. And, well, you can just look at it yourself. If b is positive, you're up here, and delta is going to be pi over 2. And if b is negative, you're down here, and your delta will be 3 pi over 2. Or perhaps you can think about it as minus pi over 2. So the cases are rather straightforward. Let's go experiment with this thing a little bit in decimals and see some of these, especially with respect to amplitude. It's very clear. With respect to phase, well, there's a bit of more complication there. Let's see if I can bring my decimals up. and erase my current formulas. So suppose I have cosine of let's say 2t. Let's write this thing as y is equal to cosine of I did was zoomed out, so the picture looked funny. So this is the cosine. Let's draw. You notice that the amplitude of this thing is just 1. It's a basic cosine. Frequency of it is 2. If I take this thing and multiply by 3, well, the amplitude becomes 3 times as big. Let me zoom back in. So now the amplitude has become 3. Now let's go try another one of these functions. Suppose I have 4 cosine of well, let's see, sine of 2t. So this is the red curve. So the black one is the cosine. It comes to the height of 3. The red one comes to the height of 4. That's the sine function. And now the question is, what if I add the black and red? What do I get? Simple question we can ask is, what would be the high point of it? What's the amplitude of it? This one is 3, that one is 4. But notice that these two high points occur at different spots. So we should not expect that when you add them, the maximum becomes 7, because these two heights are not arrive at the same time. Let's see what happens. So it says y is equal to 3 cosine of 2t, and then to that I add 4 sine of 2t. The colors are very similar to each other. Let's see if we can change it. Left click makes it green, and let me also expand this thing some. How do we expand it? Sorry, I changed the wrong thing. I want to expand only in the x direction, so I'll go from, say, -4 to, this was too far out, to 4. Okay, our picture a little bit cleaner now. We can look at it without getting drowned in too many lines all at the same time. Let's remember, the black one was the 3 cosine, the red one was 4 sine, all same frequency, and the green one is the sum of the black and the red. You notice where the high point of this thing is? The high point exactly at the length of the hypotenuse of a right triangle whose legs are 3 and 4. That's where the height is going to happen. High of 5, low of -5. Also, compared to where this height occurs, this one occurs a bit later. So that is what is connected to that is the phase shift or the phase lag. We are occurring later. So let's go ahead and explain this thing a little bit with trigonometry. Take a look at a couple of problems, and then you'll have similar things in your homework, and it's going to be short and sweet and everything. So let's see. Okay, so these are our formulas. What's the justification for these? It all comes back from your trig class. You remember in that trigonometry class you had sine and cosine of sum of two angles or difference of two angles. Let me see if you remember. What was the formula for cosine of, say, alpha minus beta? Three classes either happen to be very just surface material in high school or too fast in university, and somehow not much of it stays with the student. Even though all the formulas that you see there are about 6 dozens of them, they all occur in various places in your future classes after calculus. All of these things get to be used one place or another, but when they get to be taught on a very fast scale, or when they touch on the surface only, not much of it stays with the student. But anyway, cosine of alpha minus beta. Let me see if I pause for a second, and if you can reach a conclusion as to what that was. Try to remember that formula. They all sound like each other, and the clue, of course, hard to memorize them unless you use them on a repeated basis. So did you remember what it was? See, on the right hand side becomes cosine of alpha, cosine of beta, and then what? Plus or minus? It's plus sine of alpha, sine of beta. So if I have r cosine of omega t minus delta, this is same as r cosine of omega t cosine of delta plus r sine of omega t times sine of delta. If I want to make such an expression to match a given expression such as a cosine of omega t plus b sine of omega t, then well, a coefficient of cosine should match the coefficient of cosine here, which is r cosine, and b, which is the coefficient of sine, is to match this one. So if that formula wants to work, these are going to be requirements. So well, then I will have a is equal to r cosine of delta, and b is going to be r sine of delta. Well, if you pay attention, these are exactly transformation formulas from so-called Cartesian planes and the polar coordinates. That's what you see in pre-calculus. And to go further, for example, you can square both of these things. So a squared is equal to r squared cosine square of delta, and b squared is equal to r squared sine square of delta. If I take these two and add them, then I get a squared plus b squared is equal to r squared times cosine plus sine squared, which is the famous Pythagorean formula. Sum of sine and cosine squared is what? You're right, it's just 1. So the connection between the net amplitude or resultant to A and B is that r squared is sum of square of those two. So we have to choose a sign for r plus or minus, and by default, pretty much everything, everywhere they take the positive answer. Second thing that you can do to these two, for example, you can take this formula, divide it to that. So if I take b over a, and the ratio of these two becomes tangent of delta. But the issue is, if both b and a are negative, the ratio becomes positive, and your calculator is going to give you an answer in first quadrant, while when b and a are both negative, it means you're in the third quadrant, and to get to that location, you would need to add a pi to your answer. So that has to do with some properties of the trig functions, and cannot be avoided. Let's go ahead, just do a couple of simple examples here. Suppose we have, so say u is 3 cosine of 2t plus 4 sine of 2t, just the one that we looked at in decimals. So this becomes r, or maybe we draw a picture first. That would be the best approach. A is 3, B is 4, hypotenuse is going to be 5, so that's the easy part of this. And this delta, make sure always you eyeball it so that your answer will be close to what you get from your calculator, so in case you press the wrong button or something, you catch your own mistake. So in this case, it is, we are obviously saying that delta is in the first quadrant, tangent of delta is the ratio opposite to adjacent, 4/3, so delta becomes tangent inverse of 4/3. So you find it from your calculator using either degrees or radians. You pay attention to the two options that you have when you are reporting it. If it's radians, you can set your calculator to give you radians, or after you get it, you can do the conversion. Okay, so how do we write this answer? If you want to write it theoretically, you say the resultant is 5 cosine of, in this textbook we go with cosine of 2t, and then if you want to write this thing as it is, that's fine. If you want to convert to this to a decimal number, check to see if you are required to report in degrees or in radians, and then you just write that number. Now, if we have same situation, our r will be same as before, because when I square these numbers they become positive, so it's still 5. But in this case, delta, due to the fact that a is a negative number, whenever this is negative, don't care about the other one, when your a is negative, you have to add a pi to this, so this becomes pi plus tangent inverse of 4/3. So for the moment you strip the signs away, you push it to become in the first quadrant, and then you correct and put yourself in the correct quadrant. That's probably the best way to approach this thing. So in the third quadrant, we are going to have an additional angle of pi to go there. So our u becomes 5 cosine of 2t minus, now this pi plus tangent inverse of 4/3. Of course, when I write this thing, I am implying that everything is going to be in radians now, because I'm using pi. If I was using 180, it will be degrees. So this is this notation is pushing us to write in radians. Okay. As I said, this is something that comes up here, used a bit in differential equation, but you are going to use it significantly in electrical circuits and lots of other signal analysis and so on. Okay, so this would be a short lecture. Our next lecture is going to be on forced oscillations. That's when you have an external force in addition to all the other components of the problem we have been looking at. Once we are dealt with forced oscillation, after that we are going to go to topic of Laplace transform, and for the rest of the semester that's what we are going to cover. Okay, until then, good luck and God bless.